Hi dears, this is Raji. We are learning how to express the concentration of a solution, right? There are different ways to express the concentration of a solution. Out of that, we already learned about the percentage, strength and molarity of a solution. Okay. In this video, we are going to learn about a new term to express concentration, that is molality. Okay. So first we will see what is molality of a solution, and we will be doing a number of problems related to that. So that you will become perfect with it. Okay, so let's start with it. See this one. So what is molality of a solution? It is defined as the number of moles of the solute per kilogram of the solvent. Remember, this is not solution, but this is the mass of the solvent and that should be expressed in kilogram. So in the previous video, we were learning about molarity. What's the difference between molality and molarity? See this one. When we speak about molarity, we are expressing the number of moles of the solute present in 1 liter of the solution. Whereas when we speak about molality, we are speaking about the number of moles of the solute present in 1 kg of the solvent. Remember, this is not solution, but this is only solvent. Got it? See, when I was learning, I used to memorize like molality. Whenever lity is coming, that is not liter. Okay, yes. To understand molality better, we are preparing 1 molal glucose solution. Okay, so how to prepare 1 molal glucose solution? Okay, for that we are weighing exactly 1 kg of water. And now we will have to take 1 mole of glucose. What will be the molecular formula of glucose? That will be C6H12O6. So calculate the molecular formula of glucose. It will be 180 gram per mole. Okay. So what we will do? We will have to weigh exactly 180 gram of glucose. Okay. Then after that, we will have to add this glucose into 1 kg of water and stir properly. That's it. So this solution will be containing 1 mole of glucose is present in 1 kg of water. If so, this is 1 molal glucose solution. Agreed? Remember, when we speak about the unit of molarity, we will be using capital M. Okay. Capital M for molarity, right now? Whereas, what will be the unit of molality? We will be using small m. Understood? Okay. So, if we have 1 mole of glucose in 1 kg of water, that is 1 molal solution we will say. Okay. Suppose if I would like to prepare 2 molal solution of glucose. So what we will do? We will have to weigh 2 moles of glucose and that should be dissolved in 1 kg of water. Okay. Suppose I don't have 1 kg of water. Instead of 1 kg, I am taking 500 gram of water and dissolving 1 mole of glucose in that, right? That time, how to express molality? The problem is there in the next page. We will do that. See the question. Calculate the molality of a solution that contains 3.4 moles of solute in 500 gram of the solvent. So they are asking about the molality of the solution, right? So first of all, write what is molality of the solution. That will be equal to number of moles of the solute divided by mass of the solvent in kilogram. Correct? So write it. What will be the number of moles given? That will be equal to 3.4 moles divided by mass of the solvent given is 500 gram. But that has to be converted into kilogram. So what we will do? We will divide it by 1000. Okay. 1000 gram will be equal to 1 kilogram. Correct, no? Okay, so gram cancel and we have now converted that into kg, right? If you are calculating this one, you will be getting the answer as 6.8 molal. That will be the molality of the given solution. Got it? Yes. Now we will see another simple question. Calculate the molality of 20% of potassium iodide solution by mass. Okay. So what do you mean by 20% solution? We had discussed about that in the first video related to concentration, right? No? Yeah. What is mass percentage of the solution we were discussing? If you haven't watched that, yeah, you can click this link. Okay. In 20% potassium iodide solution by mass, we will be having 20 gram of potassium iodide, and that will be present in 80 gram of solvent. Correct? No? So out of 100 gram of the solution, 20 gram will be the solute and 80 gram will be the solvent. Okay, that is the meaning of that. Okay. Now, using this, how can we calculate molality? First you write what is molality. Yeah. To calculate molality, we need number of moles of the solute as well as mass of the solvent in kg, kilogram. Right? Yes. Here, what will be the number of moles of the solute? We will have to calculate it. What is the shortcut formula to calculate number of moles? Number of moles will be equal to given mass divided by molar mass. For that, again we need the molar mass of potassium iodide. What will be the molar mass of potassium iodide? Potassium will be 39 plus iodine will be 127 gram per mole. So together if you are calculating, you will be getting 166 gram per mole. Agreed? Yeah. Now substitute here. Mass of the solute will be equal to 20 gram divided by molar mass of the solute. Molar mass of potassium iodide is 166 gram per mole. Okay. So gram will be cancelling and you will be getting the number of mole as 0.120. Correct? Now substitute the value over here in molality. Number of moles we got already 1.20 mole divided by what will be the mass of the solvent? That will be 80 gram. But that should be expressed in kilogram. So we will have to divide it by 1000. So we are directly writing it as 0.080 kg. What will be the answer? You will be getting the answer as 1.5 molal. Okay, this will be the molality of the resulting solution. Got it? Yes. Now see this question. Calculate the mass of urea required in making 2.5 kg of 0.2 molal aqueous solution. So what they are telling? Finally, you should have 2.5 kg aqueous solution. That means it will be containing the solute plus solvent. Solute and solvent together will be weighing 2.5 kg. Agreed? And the molality of that solution should be 0.25 molal. To prepare this type of a solution, what will be the mass of urea required? Yeah, they are asking. So sometimes we will be reading the problem randomly and directly we will be substituting that. Okay. Oh, molality is given 0.25 molar. Mass of the solvent is given. Okay. That is 2.5 kg we will write. From this, number of moles can be calculated. Thereby, weight of urea also we will think. Yeah, the answer will be wrong. Okay, what is the reason? Because 2.5 kg is the mass of the solution, not the mass of the solvent. Right? No? Okay, so this method is not practical. Okay, then how to solve the problem? See, in the problem, it is specified that the given solution is 0.25 molal aqueous solution. What do you mean by that? If it is a 0.25 molal solution, in that 0.25 moles of urea will be present. Right? Yeah. And what will be the amount of water? That will be 1 kg. Okay. So, we have the mass of the solvent. Right? Yeah, and number of moles of the solute. Right now, yeah, from that, is it possible to calculate the mass of the solute? Yes. Yeah, what is the shortcut formula? Number of moles is equal to given mass divided by molar mass. So, what will be the mass of urea? Number of moles into molar mass. Okay, yeah. So number of moles is equal to 0.25 into what will be the molar mass of urea? Molar mass of nitrogen will be 14 gram per mole. Hydrogen will be 1 gram per mole. Carbon will be 12 gram, right now, and oxygen will be 16 gram per mole. See, molecular formula of urea is given. So, if you are adding all this together, you will be getting the molecular mass of urea as 60 gram per mole. Correct, no? If so, what will be the amount of urea that will be present in the sample? That will be equal to 15 gram. Okay, yes. Now we have the mass of the solvent that will be equal to 1 kg or 1000 gram. Now we have the mass of urea, the solute also, that will be equal to 15 gram. So if you are adding the mass of the solute as well as solvent, you will be getting the mass of the solution, that will be equal to 1015 gram. Correct? Okay, yeah, this will be the mass of the solution. Got it? So we came to know that 1015 gram of solution will be containing how much amount of urea? That will be equal to 15 gram. Okay. Yeah. What will be the mass of the solution given now? That is 2.5 kg. Let's convert it into gram. 2500 gram. Okay. Of solution will be containing how much amount of urea? That will be equal to 15 divided by 1015 into 2500. So that will be equal to 37 gram. So if you have 2.5 kg of the solution having molality 0.25 molal, okay, that will be containing 37 gram of urea. Did you get it? Yes. Now see this question. This is also an NCERT question. If the density of some lake water is 12.5 gram per ml and contains 92 gram of sodium ions per kg of water, calculate the molality of Na plus ion in the lake. See, in the problem they have mentioned about the density of lake water. So seeing that, people like me will jump upon and work on density. Okay, but think about, is it required in this problem? They have given the mass of sodium ion. Okay, so you write it. Mass of sodium ion will be equal to 92 gram. Okay, yeah. If you know the mass, is it possible to calculate the number of moles? Yes, we have a shortcut formula. Number of moles is equal to given mass divided by molar mass. Given mass will be equal to 92 gram. What is the molar mass of sodium? That is 23 gram per mole. Gram will be cancelled and you will be getting the answer as 4 mole. This is the number of moles of sodium ion present. So what is molality? Number of moles of the solute divided by mass of the solvent in kg. We already got the number of moles. Now how to get the mass of the solvent? See, they have already mentioned in the problem that 92 gram of sodium ion per kg of water. That means 92 gram of sodium ions are present in 1 kg of water. Right? So you got the mass of the solvent also. So you write it. 4 moles divided by 1 kg of water. Yeah, so what will be the molality of the solution? 4 moles per kg or 4 molal. This will be the answer. So I am telling that the density they have given is only to mislead you. That is not required in this problem. Okay? Easy. Got it. We have done so many problems related to molality. This question was asked in a JEE main paper. So can you try this question by yourself? Yes. You should try it and find out the answer. You can check whether your answer is correct or not by clicking a link in the description box. There I'll be sharing the solution for this question. Hope you might have understood the concept well. See you in the next video. Till then, bye for this time. Thanks for watching.